All right, I'm just going to go into slideshow mode. I only have one physical screen, so I presume right now you can see the presentation okay.
Yes, and it's in present mode, so you're good.
Perfect. Okay, well, great. Well, thanks so much for having me here today. I'm going to be talking about risk-based testing, which I call Run the Risk. And slide down. There you go. And just a few words about me first, just to if you want to get in touch with me. I actually come from the developer side of the world. I was a programmer from an early age on such 8-bit computer systems that people maybe my age remember, and I won't mention because it might date me. Currently, I'm a director of technology at Inflectra, and we're a software test product company. So we produce tools to help software testers and managers of testers. So if you're interested in anything you hear today, feel free to connect with me on Twitter or LinkedIn. I will say I'm probably more active these days on LinkedIn than Twitter, but I'm on both. So feel free to do that, or you can email me at my email address as well. So again, hope you enjoy this presentation. Happy to keep the conversation going afterwards. So the purpose of this presentation is really to give you an idea of what is a risk-based approach to testing, or what we call risk-based testing, and how does it give you a better outcome. So I'm going to be talking about what it is, how it gives you better outcomes. I'm going to talk about how you can use project metrics. This is data that you already have today, hopefully, to create a test plan that is adjusted for risk. And then I'm going to look at some practical examples of tools and techniques you can use to implement the test plan that we're going to go through. So first of all, let's talk about the types of risk. What is risk? What are types of risk? I'm very passionate about risk management. Like Jenna said, it's an area that I think is often forgotten about, or it's siloed. It's a really important area, and I think in the last 2 years, everyone would agree that risks are something we have taken for granted or underappreciated. And I want to then look at specifically how you take risks and risk management, apply it to the process of test planning, and building out a test plan that will be based on risks and using risks to help prioritize what work you do. And we've got some examples and use cases and some spreadsheets and things you can use to try and take this home and make it actionable. So first of all, what is risk-based testing? Well, if you go online and search for it, which I did, you can find out it is a methodology for testing which is based on using the probability of risk to improve the planning of testing and the execution of testing. But basically, using the probability of risk to improve software testing. Now, but what is risk? And I don't assume you have a PhD in risk management, so I'm going to sow the groundwork with a little bit of general risk management overview. First of all, risks are something that can happen in the future and might happen at that point in the future. Big difference. People always talk about issues. Issue is something that's happening right now. So if there's an outage on the system, that's an issue. A risk is something that could happen, like the system might go down, not the system is down. Risk actually can be positive, though, and most people think of risk as being negative, something that could happen that's wrong, that's bad. Risks can also be benefits. They can be positive, so winning the lottery is an example of a positive risk. However, generally, when you talk to someone who works in the risk management field, you're usually talking about negative risks, things that are detrimental to the success of your project, success of your system, or success of your organization as a whole. So generally speaking, we're going to be talking about risks. You can think of them as being the negative risks, but they don't have to be in a pure sense. So for example, the system might not handle the possible future load is a future risk, and that's something that you would have to plan for. So just to recap, risks are things that could happen in the future, and in this case, we're going to be focusing on the negative ones, but they can be positive also. And so typically, when you're working on software systems and systems in general, there are 3 broad categories of risk that I think people should be most aware of. And if you're a project manager, you should be very aware of this. In general, there is the idea of, well, we've got to build something. We're designing a system, we're building it, we're going to show it to users, and hopefully it will do what they want. But the big question really is, are we building the right thing? We can spend all this time building this amazing piece of software, but when you give it to a user on first contact, it doesn't solve their business need. And that's really the conceptual risk. Are we building the right concept? Is it the right concept we're designing and developing? Let's say we get that. We figured out what they need, and then we try it, and it doesn't work. It's too slow. It doesn't work on their network. Maybe we didn't realize the telecoms they were going to have. Whatever it is, it doesn't technically work. So it is the right concept, but it's flawed technically. That's your technical risk. And the last one is, well, it's great to have this amazing idea. The technology will support it, but it's going to take 10 years, and we promised it next year. Well, it's not. That's the schedule risk. So generally, you're always looking at balancing the effort spent on understanding and mitigating conceptual risks, technical risks, and schedule risks. Now, if we are using an Agile methodology, Agile can actually help. And one of the reasons why Agile has become so popular in general for software development and product development in general is the fact that it helps to mitigate some of these risks which are inherent in software projects. So first of all, conceptual risk. Well, what we realized was people are pretty crummy at writing requirements. We don't often do a very good job of it. But if you can show someone something and they see it, they can grasp the concept so much more easily. I mean, there's a great presentation from Steve Jobs when he introduces the very first iPhone, and he tries to explain to what it is. And it's hard in the beginning to understand what he's talking about. But once you see it and he shows it in action, he makes a phone call, orders a pizza and stuff. It's a cool video to watch, especially now, these many years later. We all understand what a smartphone is. We all have them. We've all got our iPhone and we all Android, and we know exactly what this is. But that's 10 years later. So it's very hard for people to understand something until they see it. So in Agile, we have this great ability to give them a minimum viable solution, something they can see, something you can give feedback on, and then we iterate. So with that, we reduce the conceptual risk. Agile also has an approach that helps deal with the technical risk. We try and do what are called spike solutions. We code the most complex things first. We test the most complex things first, not the things that may be the most business value, but sometimes it's the ones that are most technically risky to make sure that the technology is actually proved out. And that means if we don't find it working, we can change course, change our architecture, whatever it is, that we try and understand the technical risk early. And the last thing, of course, is schedule risk. Because we release in small increments, if there is less time available, we can still deliver value. It isn't like we have 6 months of design work that we have to just give to someone and say, oh, well, we spent 6 months, there's the design, have fun. We can say, well, it does 60% of the functionality in half the time. You can now go live with that and do something else. So it gives you the ability to manage schedule risk by having something always real all the time. Okay, so that's how Agile helps to understand, to mitigate some of the common risks. However, what are risks and how would we start thinking about risks on our project? So even with Agile, there are still risks that we have to deal with. So one of the things you can do first of all and should do is brainstorm with a team, whether it's in person or virtual, build out what's called the risk breakdown structure. And that should be holistic. Everyone will always think of the obvious ones like, oh, the system's going to be too slow. What's the performance going to be like? Security risks, et cetera, et cetera. But there could be other things. It could be people risks. Are we going to have enough people to be able to view the product to give us that feedback? Is the product owner going to be available? Are we going to have access to the end users? Do we have the right technology? Do we have enough budget to pay for the Amazon hosting? Think of all the different things that could go wrong and sort of like the worst case assessment. Any idea, however unlikely, and however dangerous or maybe even ridiculous, have a brainstorm session and lay all that out. Once you've got this giant hierarchy, what you'll do is you'll try and categorize it by the kinds of risks. So you get a structure like you see here. Take the highest level categories and brainstorm all of the time risks, all the people risks, technology risks in each category. Make sure you've got a good definition of all the risks. Now, once you've figured out that you have a whole bunch of risks and you've scared yourself, the next thing to do is to think about how bad are the risks. And people have a very hard time generally estimating which risks to worry about. It's one of the things where as a human, we're not geared well to understand. So the first thing you should do is independently figure out how likely is it. Don't worry how bad it is. Is it going to be terrible? But it's just how likely is it? And you can score it 1 to 5. You can score it on a Fibonacci series or one or geometric 1, 2, 4, 8, whatever it is. Come up with some methodology, but you want to be able to rate the risk purely on its likelihood. Then put that to the side and forget you even did that, and now measure the risks by impact. How bad is it? Again, don't worry if it's not going to be very likely. Maybe it's a lightning strike hitting something. That's probably catastrophic, but not very likely. So you want to really focus on those two independent measures. People have a much easier time independently measuring these two values than they do assessing how serious a risk is. So what you do there is you put these two together then, and now you get your exposure, which is the multiplication of your probability and your impact. And if there are things that are certain and catastrophic, they are almost like issues. They're going to happen, and if they happen, they're really bad. So you're going to want to look at those ones. But I would also say be really careful. People tend to over-focus all their attention on the top right, which makes sense because it is the most likely and the most dangerous. But also, there are things that are maybe possible and likely, and maybe they are critical or catastrophic. And those ones are things that could still happen. Maybe it's 50-50 chance. If that chance happens, it's still pretty bad. So don't just look at the top right quadrants. You have a reasoned judgment. Look at the things that are possible and likely. anything in that top 3 by 3, possible, likely, certain, and catastrophic and critical, certainly the top 6, those are the ones you should really look at. But again, look at all of them and understand where your risks are and where you need to focus. But again, don't obsess about just that top one right cell, because there are things that are just slightly less likely to happen that are almost as bad, and we tend to overlook those. So now that we understood we have a whole bunch of risks, we've categorized them, we know how exposed we are for each of those risks, we now need to think about what can we do about it. And that's called, in risk management theory, a mitigation, something that we can do to make the risk less. So you can either reduce the likelihood or you can reduce the impact. If we take an example of lightning's going to hit our data center, then one mitigation would be put a lightning. One thing is we can't stop the lightning happening, perhaps, but we can take action. So we'll have a backup data center. So if it's an X chance of lightning hitting it, don't worry. If it does hit it, it won't be as catastrophic because we've got a second center. The other possibility would be, well, we can't afford a second data center. Let's just reduce the likelihood of lightning hitting it. Now, if lightning hits it, it's still going to be just as bad because there's no backup. But we can put a lightning rod up, and then it won't hit so much. And in reality, you probably want to do both because you can't rely on just one. So you take multiple actions to reduce the risks. Okay, so that's the basis of risk management. You're now a risk management expert. You can now manage risk plans and mitigations and all that good stuff. But that's really what risk management is. It's about identifying future events and then mitigating them in some way. And actually testing is a way of mitigating them. So because, of course, what is the purpose of testing? Why do we test things? Well, for a tester, that's because we like testing and we love the challenge. We love the thrill of finding something and covering something. But from a business user, for the product owner, the reason why they want testing to be done, why they like having testers or being testers, is because ultimately you're trying to understand what is the risk in this system. And in particular, the technical risk and sometimes the conceptual risk can be uncovered by testing. It's basically finding things that are wrong with the system and that you need to then address. It doesn't mean they're all going to get addressed. We know that we won't fix every bug. We're just going to reduce the risk of the system to an acceptable level to release. And that's when we go live with the system, we decide to go live. We may go live knowing there's some issues. And we're doing that in the risk management world. What we're saying is we've mitigated the risks by testing and fixing. And we have mitigated the risk by testing and maybe having some workarounds or documentation. And at that point, we've mitigated the risk to the point where we can go live knowing whatever risks still remain. And we're comfortable with that decision. So that's the whole point. So again, testing is it's one of the ways we mitigate risk and reduce risk. However, the problem is there's never enough time for testing. And as this famous Steelbook cartoon that's in almost every presentation we see around this topic says, there's never enough time for testing. You can automate a lot of your tests, and people are doing that more and more, particularly lower down the test pyramid, unit tests, API tests, all that stuff. You want to automate as much as possible. There isn't necessarily enough time to automate everything. There's certainly not enough time to run manual tests of the things you couldn't automate. So you're always going to have to make a decision about where to invest time. If you do automate, you want to automate the most repetitive, most mundane, most, annoying tests for a human to do. So things that can be done that take a lot of time to run, but don't take a lot of time to write. Automate those first, and then progressively, bite down on the different tasks that perhaps could then be automated. So you'll eventually have some degree of automation, some degree of manual testing. If applications are changing with Agile, it's unlikely you'll automate everything all at once, all the time. And even that will take time. So the key is figuring out, with the finite time we have, what do we do with it? Where should we spend our time? Which parts of the application should we spend our time in? Which tests should we run? That's the whole purpose of using a risk approach. So first of all, since we have a whole bunch of risks we've identified, imagine this was your risk register on the left. We've identified the risks, and again, there's about 10 here, maybe there's in real life 100 or so. And we take all those risks and we basically rate them by probability, we rate them by impact. We now know the exposure. So let's say the top 5, the 8 through 12's exposure, they're pretty bad. What we can now do is start to then create tests that explicitly mitigate those risks. And we can either create one test for a specific risk, maybe there's several different ones. But you're taking the items on the left, the risks, and we're gonna now build tests out to explicitly mitigate and verify those identified risks. We did this internally, actually, a recent exercise we're doing it for cybersecurity. We put the OWASP top 10 and a bunch of other risks that we identified, put them on the grid. We did the same probability, impact, and exposure calculation, and we built out an action plan and test plan for those. So you can do it for lots of different domains: performance, cybersecurity, general business risks, technical risks, functional testing, all the different aspects this approach works for. Okay, then once we've done that, we then map those test cases to our exposure. And initially, we have an initial at least prioritization of, okay, well, the test cases that mitigate the most exposed risks we've marked in red. The test cases, test case 1 through 10, that mitigate the ones that are slightly less exposed are yellow, and the ones that mitigate just the ones that are the lowest risks are green. And if there are any tests that mitigate anything, they're white. So those ones we shouldn't bother with. So at the highest level, we've taken our human identified risks and we figured out which tests mitigate them. But it's not sufficient because what we identified as risks from a brainstorming exercise is very much an intuitive way of looking at it. But we have real data, so we can actually do more than that. We can use the data in our system to figure out where some other risks might be. And so to do that, we're going to use the data that we have. And depending on the tools you're using and the data you're collecting and the metrics you have, some of this will be easier or harder. And it's certainly worth trying to collect more of these metrics to allow you to do more of this. So first thing is, if you're managing requirements, now this could be a waterfall project where you've got requirements. It could be an agile project where you have stories, features, and epics. You probably have some non-functional requirements, even if you're doing agile, and you should do anyway. And so you've got a whole bunch of requirement-like things. Again, I'll use the word requirement, but it could be a backlog item, it could be a feature, epic, whatever methodology. They're effectively requirements. Let's just call them that. So you take all the requirements, and those have got a business priority. And if they've got a high business priority, we can assume that the business cares about them. And if they're a low business priority, the business probably cares about them somewhat less. So what we can do is do the same thing, take all of our test cases, manual, automated, whatever it is, and we'll map those against those requirements by priority. So we'll now know which tests cover the most important business features, because if a business feature that's really important fails, that's got higher business impact than a feature that's less important. That helps you measure the impact. So basically, once we've mapped our tests to our requirements, we are basically creating a impact measure to see these tests will affect the most impactful features effectively. What about stability? So if you run a test and it passes and fails and passes and fails, you might say, oh, it's a flaky test. We have those, particularly automated tests. It's flaky. We don't worry about that. But tests that repeatedly pass and fail, to me, they indicate the probability of a problem. It doesn't mean there is a problem. The problem could be that the test truly is flaky, but you shouldn't assume that. We had a situation in our internal product, one of our own products, where we were running tests and it was an automated suite and it kept passing and failing every other build. And our first reaction was, oh, it's a flaky test. Don't worry about it. And when we actually did some analysis, we actually had a customer have a problem. So we did an analysis. It was actually a race condition in the code. So the code itself, the actual system, was firing things in different orders indeterminately, and it wasn't meant to do that. So we actually had the situation where data wasn't updating in a stable order, which actually could affect reporting in the system. And the test was correctly seeing that. So we had as a flaky system, not a flaky test. So whenever you see tests that tend to have historically up and down situations, it could be a manual test where different tests are having different results. There's a probability there that something's not quite right. You shouldn't have that. So that doesn't necessarily mean it's a high impact issue or risk, but it certainly is a high probability risk that you need to look at. Another area that I would look at very carefully is what we call the requirements defect density. It's a bit of a mouthful. What it basically means is, well, we've got some requirements, we run tests on them, and when the tests fail, we log defects. And we know which requirements those defects belong to, okay? Well, that's good. So what is that? That really is helpful because what that means is I can look at those requirements and see, wow, do they have a particularly high number of defects versus the others? In this example here, everything's kind of got a 2 or a 3 or a 1. It's not particularly important. But sometimes we've gone through this exact same exercise, and the one at the top, because this is ranked by most open and most total defects, would be, imagine with that top one, instead of saying 3, you said 9. So we've got one requirement that has 3 times as many defects as the others. So why would that be? It could be that the requirement is just very complicated. Maybe we've just been testing it a lot more. So we're not sure, but there is certainly a probability of more problems, more issues with that, because there's so many previous defects. So if you see a requirement that has got a historical number of failures, even though they've all been fixed, it implies that there's something most likely was not done correctly in design, development. It's flaky, the spec wasn't as good, the story was unclear. Whatever it is, there's many reasons, but there's certainly a probability that there could be future problems there. Doesn't mean that they are. Remember, risk is not about what has happened, it's what could happen. So there's certainly a higher probability of something. So when you look at those requirements, the ones that have the most historical number of defects, they have a higher probability of future problems. Another thing that's very useful, particularly if you're doing a user interface type of application, if this is something that the users don't use, it's more of a machine-to-machine or an API type application, maybe a bit less so. But certainly, looking at the user flow, the critical user flow. So imagine you have a login page. The login page, people don't usually rate as very high functionality. Like, oh, the business doesn't say it's a priority one. Of course, we know there has to be one, but it's fine. It's just a login page. Not very important. But imagine if the login page isn't working. You can't get to any other page in the application, potentially. That's a big, big problem. And obviously, login page is an obvious one, but there may be other key pages. There may be other pages in your application which are gateway pages to other parts of the app. And if any of those break, they're not necessarily more likely to break, but if they do break, they're going to prevent people getting to any other parts of the application. And so that's going to have a much higher impact on your testing and on the business ultimately. So if that page is down, the impact is much bigger, is huge. The risk to the business is huge versus a page that only is used when you get to that page and it doesn't go anywhere else. Okay, if it breaks, it's not good, but it doesn't impact the rest of the application. So finding these gateway pages where people are funneling through is really important. And to do that, you can use tools like, this is actually from Google Analytics. Just go to tools like Google Analytics, and there are other tools, things that follow the user flow, and look for bottlenecks. Look for pages where everyone flows through. And if everyone's flowing through one or two pages, those pages are hypercritical because those are gateways to other parts of the app. So it's a really useful technique to find critical pages that may not be missed because they may not rank highly on the business priority. Maybe there haven't been many failures before, so they're not particularly likely to fail, but they are still mission critical to your business and to the application. Another possibility is code commits. Code commits are when people start to commit code against a particular feature, and that's a good thing, right? You want to have commits, people fixing things, adding functionality. But imagine you start to tie that back to the specific requirement of the specific module. If you could do that, if you have a whole bunch of commits in the last 2 days before release to one feature or one module, human nature being what it is and people making mistakes and the chances of things being done incorrectly, it's more likely there's an issue there than a part of the system that hasn't been touched in 6 months that's in the previous release. If I was going to figure out where I want to spend my testing time, it's probably on the areas that have changed most recently. Just because it increases the likelihood of something being wrong, it doesn't necessarily mean there is something wrong. Again, it's probability, it's risks, not actual things that are wrong. Okay, so that's a lot of stuff. So, but if you put it all together, this is the key. And this is the slide. If you can take a picture of something or look at the slides, this is the one I think is the most important. We're putting all of it together. So what we're now seeing right here is the overall risk matrix. So there's lots of pieces going on here. First of all, the top part is what we saw before. That's where we have all the risks lined up. We spent doing our brainstorming exercise. We've ranked them by probability. We've ranked them by impact. We've got the exposure. We've got the number of test cases. We did that already. Remember that from before. But now we've got this exact same type of grid. But now we've taken all the requirements, and we only have 5 here to make it simple. And we've added the business priority. So the first 2 are high, the second 2 are medium, and the third one is low. Great. We've also put in the number of defects that we've experienced against those requirements. And we flagged the third requirement because it has 10 defects historically. The others have 1 or 2, and the fourth one has 4. So we ranked the one that was with 10 as red. We ranked the one that had 4 yellow. The rest we left as green. And then we looked at code commits, and we found that the very first requirement had 20 commits in the last release. The others had a much smaller number. So as you can see, we've basically color-coded it with anything that was a priority 1 is in red. Anything that had a number of commits 20 is red. The one that had 10 defects is red, and things like the defects number being 4 and the commits being 4, we put as orange. Now we map those requirements to our same test cases, so the vertical columns are the same as the ones for the risks. TC1 to TC10 are the same test cases, but what we did now is we added in these rows and we've color-coded it, so every time you get a red on any of the 3 metrics, priority, defects, or commits, we gave it red. If it was simply in the middle, we gave it a yellow. Otherwise, we gave it the kind of a green or an orange. And we put that all together, now taking each of the vertical columns for test case 1 through 10, anything that had a red of any of the rows, we made red. It's similar for the other colors. So that bottom row where you see overall, that gives you an overall risk-adjusted way of looking at the test cases. So we have 10 test cases. If we didn't have this matrix, how would we decide if we only had enough time to run 5 of them? Well, maybe we pick the first 5. Maybe we pick the last 5. Who knows? What we do now is we can say, well, the ones in red, let's do those first. So test case 1, 2, 5, and 6, and 8. So 1, 2, 5, 6, and 8. Those are the highest risk test cases. So if we can run just 5, we'll do those 5. If we more time, we could then potentially run test case 4, test case 7, and test case 9. And only if we had enough time for all of them would we do test cases 3 and 10. So basically, we've now got a prioritization system that takes those different risk measures, puts them together, and lets you figure out which tests should be run. So what would Donald Rumsfeld say? And some people probably won't like me using his name, but a much maligned and fairly maligned and Secretary of Defense. He did many bad things in the world, but one of the things he did that was interesting was he coined this phrase. There are known knowns, things that we know we need to do. So as a developer, there's the user story you have to code. There are the known unknowns. We don't know the performance of this system, but we know we need to measure it and figure it out. Then there's also the unknown unknowns, the things we don't know. And so the one challenge I would say is with this risk-based approach like this, we've figured out what are the known unknowns, and we've plotted them and we've mapped them out. And we've decided which of those known unknowns are the ones we think are going to most likely occur. And if they do occur, will have the biggest impact. So test case 1, 2, 5, 6, and 8. Those are the biggest risky known unknowns. But what about the unknown unknowns? And that's really the idea that even if we do this risk-based approach, we need to still think about things that we don't know we know. And the risk-based methodology here is not going to necessarily find those. So you need to make sure that whatever you do in your planning, don't plan out the schedule to such a degree there's no time left to experiment, to find them. And so what I would say is use techniques like exploratory testing, free-form testing, session-based testing. There's much in the industry. In other talks, you'll hear about this. Exploratory testing and other free-form techniques are really good because they let you find things you didn't know you needed to find. Imagine this was your system, user stories, requirements, automated tests. We've used our risk-based approach. We think we know the system and all its flaws. The real system looks more like this. There's always things we don't understand, things that we developed in a way that we didn't understand the side effects when these two modules work together or this code and that code interplay. The developers of both systems couldn't have foreseen it. If that wasn't the case, there'd be no security breaches. So clearly, there are always flaws in things because we're fallible and we're human. So therefore, those edge cases, the difference between the system we thought we built and the system we built, basically, those are the edge cases we have to deal with. And so tools like exploratory testing are really good because basically they will find them. Not all of them maybe, but they certainly will be a good way to look for them at least. So when you're building out your test plan, don't stuff it so full of test cases and test plans, things that the risk identification process has shown you that there is not time at the end to find other things, because otherwise one of those unknown unknowns might trip you up. So the reason why I say that is because when with these methodologies like risk-based testing, it can often make you feel overly confident that you found everything and know everything, and then you're really just testing blind. So make sure you don't become overconfident. Allow time for testers to just do their own thing, find stuff, because they will, and they always do. Okay, so to wrap up, a risk-based approach to testing is really designed to take the data that you have, the requirements, the risks, the defects, the commits, other metrics that you have, and there may be other ones that I haven't thought of. This is just, again, a presentation. But think of all the ways that you can identify risk in your system, whether that's just brainstorming the risks or particular data that you have that can let you identify where something is going to have a very big impact or where something is more likely to have a problem. Use those metrics to figure out which tests and test activities you can do to mitigate the most egregious risks, the highest exposed risks. And once you've done that and prioritize your efforts, allow time in the plan to avoid the unknown trap. Make sure there's enough time left to experiment and find things, because if you don't do that, you will miss things. And if you want to read more, here's some articles on risk-based testing that you can read on the industry. There's plenty of other examples as well. As I mentioned, you can also message me on LinkedIn or Twitter. And with that, if there's any time, we'll take questions. I'm looking in the questions right now. Marion Bryn wrote VaskTech. I'm not sure what that is. So I don't see any other questions. Jen, any questions?
There we go.
Thank you.
Hey, that was great. Thank you so much. It's funny because risk is one of the things that I'm super into. So I talk about it and I think about it. And I worked in a risk-based environment. One of the organizations I worked for, enterprise level, was risk-based testing as a strategy. And it's so interesting, all of the different ways that we can approach risk-based testing. We can approach the different ways we can approach risk assessment, things like that. I noticed that you used numbers for your risk evaluation, which I do as well. But I don't know if you know Jenny Bramble. Jenny talks about some of the other, you don't? Okay, that's okay. So Jenny actually talks about some of the other ways we can evaluate risk. I'm with you. I like numbers, but I want to get your take on what some of her teams have done, which are things like emojis. There are some people who use like heat maps. Is there a reason you might have a preference towards numbers as opposed to something like that?
So it depends. I mean, what the intention of doing it is, and one of the reasons that one of the benefits of numbers would be you can weight things. So, for example, if you saw I had like, and if you notice, I had labels and I had numbers. So I think people have a hard time. Definitely, people have a hard time estimating. You ask someone, "Is this a risk 1 through 5?" People have no idea. But if you have, so I think having very good labels makes sense. Like I use catastrophic, critical. Those don't always resonate with people. So you might want to change the labels and say, listen, what does catastrophic mean? Can't work at all. Nothing works, dead. And maybe minor is, I wouldn't have noticed it unless you told me. I mean, you can use very, very, I think, human accessible labels for the probability and the impact axes. I think that's a really good idea. I just chose some, I mean, the slides I use were using some industry standard terms, which can be hard for some of the teams to figure out. So you could have emojis, you could have colors, you could have feelings, like doctor's appointments now have that 5, how did your pain feel, like the smiley faces, and there's lots of really cool ways. I think that's a really good idea. The one thing that's the benefit of the numbers with those is that you can bias it. I did a 1 through 5 scale, but imagine that critical one is not just slightly worse than the catastrophic. Maybe it's twice as bad. You could do a 1, 2, 4, 8 scale. So you can use numbers. And then the other reason I think numbers are good is because you can multiply them together to give you that heat map, the what's called the risk cube. If you don't have any numbers, it's hard to do that. And what people tend to do is they overestimate, if I remember correctly, which one ran it? We overestimate one or the other. I always forget. I think we overestimate severity, and we tend to underestimate risks that are more likely but less serious. We as humans tend to focus on the things that's going to happen and it's going to be really bad. The things that are, it might happen, it might be somewhat bad. Those are the ones we tend to do the worst on. And maybe that one is really, that 4 is almost as bad as a 5. And maybe it should be 1, 2, 4, 8, 9. I mean, because it's not linear. And I think it's really important to use numbers to try and take some of the emotion out of some of this. It's good to use emotion to rank things, but when calculating and adjusting it, the dangers are emotion and intuitive sense can blind us to the data. Sorry.
Oh, no, it's fine. What's interesting is that your reason for numbers, which I think is a good one, is actually different than mine. Although I'm going to incorporate yours because I like it. So I like that I can track change over time. I can't really do that with something like an emoji or heat maps.
That's true.
I can do it with seeing a mathematical change in the risk evaluation, because of course, it's not just what the risk evaluation is today, it's what the risk evaluation is 3 months from now after we've mitigated it.
Correct. And in fact, if you're doing anything in the life sciences or anything in the hardware space, there's a thing called FMEA, which you probably know, but the audience might not. And FMEA is the methodology used for assessing risk in industrial systems, and you have to be able to track it over time. It's not an option. You have to be able to mitigate things before the mitigation. This was the risk exposure. We've mitigated it. What's the new risk exposure? It's not an option. If you want to build systems that are going to be used in public safety, you have to do that. So I think it's really good that these techniques can be used in a way that allows people in different industries to expose themselves to this. Because if you think about Internet of Things, soapbox of mine, but we're building systems now in people's lives that people could die from. Like if that Tesla update fails, it's not like the display in your car that plays the music is going to break. The car might stop in traffic, and you could be dead. So, and yet it's the same software developers probably building these systems who've we haven't made that graduated mental leap from software as a business app that books flights and the shopping cart and all this stuff that we grew up with. We have software now that if it goes down, people can't do their jobs, people could lose lives, all that stuff. So as software developers and testers, we have this responsibility, I think, to think safety.
That reminds me of something, and I hope everybody can appreciate the comedy in this. So my father, he's in his late 60s, run companies his whole life. He was in manufacturing. And we were talking about something, and he said, well, I don't have those problems because I only buy perfect software for my organization. And I started laughing hysterically. And I said, perfect software doesn't exist. It's a myth. We want to get as close to high quality as possible, but perfect software is a myth. So this idea that we can get to no risk, that we can get to perfection, that we can fully mitigate. I don't know.
Right.
I always wind up thinking back.
That's interesting. That's interesting because as software professionals, we always realize, we may not say it, but we're like, well, as I mentioned in the presentation, well, we're going to go live knowing there's some bugs because we have made a decision that the risk is there's an acceptable risk. But that acceptable risk is not, it's not always ours to make, to decide. And what's acceptable risk in a software app being used to, order shoes online is not the same risk as a flight control system in a jet. And that's, of course, a real world example where, unfortunately, that was the case, and look what happened. So we as practitioners and people who use our tools or our methodologies or working in this field, we have to understand the level of risk that we work on in different products can maybe completely different. And if we're working in a real-time environment, it's very, very different, and we have to appreciate that. And I think the internet, unfortunately, is becoming such a fabric of our daily lives that more and more applications are becoming critical. Things that we maybe saw them as, if this doesn't work, there's a workaround. Those workarounds and manual methods are being phased out, so there won't be alternatives.
Yeah, I think banking apps are the biggest demonstration of that, because it used to be, oh, well, the mobile app is down, I'll go to the website. Oh, the website's down, I'm going to call my bank. Well, now if the mobile app is down, the website is also down, and their call center is down
because they're all using the same system, right? Yeah. And the branches closed because we closed all the branches because we had a mobile app. We didn't need the branches anymore. And even if we went to the branch, they have the same web page anyway.
Yeah. I mean, it's all interconnected. There is no getting the answer, getting the solution. So yeah, it's becoming more and more critical, and we've got to develop that risk-based thinking, because it's not just about doing risk assessment. It's also about developing the mindset, which is a whole nother conversation.
Right, and I think it's interesting. Risk management used to always be this separate discipline. You had the Scrum teams building, the project managers doing the managing, and the risk team was off in a room somewhere doing their risky stuff. And those risk people should be in the Agile teams. They should be with the project teams. They should all be together. It's not separate methodology. It's not a separate thing. It's all part of the same. Anyway.
I agree. Well, Adam, thank you so much. It was great getting to see you talk for the first time after this time of knowing each other.
Well, thank you. It's been a pleasure, and hopefully I'll see you in person and other people at an event, online or in person next year. We hope to do that. It'll be great to see you in person.
Fingers crossed, we're all going to be together somewhere.
Yes, absolutely. Thanks so much, Jenna. Have a great day. And thanks everyone for attending, and have a good rest of the conference.